Hey kiddo, it is Tuesday and I'm going to have you move forward with math just a little differently this week. Um, so I'm probably proctoring today, or I'm not going to be in school because I'm getting my shot later today, and I might just not be able to make it in because I might not feel well. But I pre-recorded this video for you in either instance, so that way you can go ahead and watch the video, and then go ahead and work on the guided practice. I'm going to give you today, which is Tuesday, and Wednesday to complete the lesson and then the guided practice. And then on Thursday, we'll go ahead and take the post test, the actual practice piece for 11.3. So then on Friday, you can go ahead and I believe you will be testing out. I will, again, on Wednesday, touch base with you and be available if you need me for this. So we are working on real world problems circles. So we're going to use the formula for circumference to solve real world problems. So we have a circular mat with a diameter of 53 centimeters. Lily wants to sew a decorative braid around the mat. How many centimeters of braid does she need? Give me your answer to the nearest tenth of a centimeter. Use 3.14 as an approximation of pi. Again, I'm going to tell you what I tell you every time we do these, even when they tell you to use fractions. So 22 over 7 instead of 3.14. You are more than welcome to just use 3.14. I will know the correct answer. So even if you're using 3.14, I'll still be able to see that you're right because they're not that different. So we want to remember that in order to find the circumference of a mat, we are doing pi times diameter. So we're going to write our formula, and then we're going to substitute in our formula. So pi, we're going to substitute 3.14, and then diameter, we're going to go back here, and it tells us a diameter of 53 centimeters. So I'm going to go ahead, plug 53 centimeters in, and then I'm just going to multiply, right? So I have 166.42, which is rounding to the nearest tenth, 166.4 centimeters. So that gives me approximately 166.4 centimeters of decorative braid. So this is just like a simple, right, like plug things into the formula. Our part B for this is going to be a little different. A metal worker cuts a large semicircle with a diameter of 28 centimeters. Then our metal worker cuts a small semicircle out of the larger one and removes it. The diameter of the semicircular piece that is removed is 14 centimeters. We're going to find the distance around the shape after the smaller semicircle is removed. So we are just trying to find the distance around the pink portion of this image, right? So we're going to have to find the length of this arc. We're going to have to find the length of the smaller arc. And then we're also going to have to include our 14 here to find the length of the distance around this smaller shape. So in order to find the length of a semicircular arc, we're going to take half of 2 pi r, right? So you can see they just go ahead, plug our numbers in, substitute, and divide. So they're simplifying here using cross simplification, right? The 2's will cancel out. We can simplify 14 to be 2, right? Because 7 goes into 14 2 times, which leaves us with 1 times 22 times 2. So we're going to go ahead and multiply, and that's going to give us 44 centimeters. So arc PQ is 44 centimeters. We're then going to move on to the smaller semicircle, so PO. Again, we're going to do the same thing, plug all of our numbers in. So here we have 1/2 pi times diameter, right? So 1/2 times 22 over 7 times 14, which is 1, 11, and 2 is 22. So now we're going to add the semicircular arcs together, which is 44 plus 22, And then that one little flat line was just 14 to give us a total of 80. So we can say that the distance around the shape is approximately 80 centimeters. Finally, we have the shape of a tabletop that is made up of a semicircle and a quadrant. We need to find the distance around the tabletop, okay? We're going to use 3.14 in our example for pi here. So again, just like last time, we're going to find the length of the semicircular arc QO for my semicircle. We're going to find the length of my quarter of the arc, PQ, and then I'm going to add those together along with my flat line, which is 60 inches. So we're going to use pi times diameter, right? So we know that if this is a quarter of a circle, that both sides would have to be the same length, right? Because we want to take out an even piece of our circle for it to be a perfect quarter. So this is 60 as well. So we're going to plug 60 in with the rest of our equation, and we are in good shape. Then we're going to go ahead and we're going to solve for the quarter. So we're going to plug in 1/2 times 2 pi r. Our radius is 60. We're going to divide that by a quarter. I'm sorry, we're going to multiply that by a quarter, which is dividing by 4 times 60, right? So we basically plug all of our numbers in. They cross simplified, so we come down to 94.2 inches. Now I'm just going to add my units together. 94.2 plus 94.2 plus 60 gives me 248.4 inches. So we can say that the distance around this tabletop is approximately 248.4 inches. So that's for using our circumference, right? So you're going to be working on the guided practice. I'm also in this video going to go ahead and talk about using area to solve real world problems. If you would like to pause the video here and work on the guided practice problems 1, 2, and 3, you may, and then come back to the video once you're done with those, right, to finish off area and then the last piece. That's fine. Remember, I'm giving you 2 days to complete this, okay? If you want to pause here. If you're not going to pause, we're moving right along, or welcome back if you did pause. So now we're going to use formula for area of a circle to solve real world problems. So I have a jewelry designer who is making a pendant. The pendant will be a circular disc with a center of O, with a circular hole cut out of it as shown in our image. The radius of the disc is 35 millimeters. From the area of, we're going to find the area of the pendant. They're having us use 22/7. Remember, you're more than welcome to use 3.14 if you are using the calculator. So when we're looking for the area of the pendant, we're looking again for the area of the pink, not including this white. So we're going to have to find the area of the whole circle. We're going to find the radius of the hole, and then we're going to subtract the radius of the hole from the area of the disc. So our area formula for a circle is pi r squared, or pi r, right? So we're going to do 22/7 times 35 squared, which would be 22 times 35 times 35. They're using cross simplification, right? So 7 goes into 35 evenly, which is going to give us 22 times 35 times 5, for the area of the disc being 3,850 millimeters squared. Then we have the area of the hole. So we're going to do diameter divided by 2 so that we can find the radius of the smaller shape, which is going to give us 17.5 millimeters. And then we're just going to plug that in. So when we plug that in, again, drop all the numbers in, it gives us 962.5 millimeters squared. So in order to find the area of the pendant, you're going to take the area of the disc and subtract the area of the hole from it. So You can see we've substituted in our numbers. 3,850 minus 962.5, which is going to leave us with 2,887.5 millimeters squared, approximately. So for B, you're going to do the same thing, right? With this one, we're using a semicircle and a quadrant. I have a graphic designer creating a design for a company logo. The design is a green semicircle with a white quadrant as shown. We're going to find the area of the green part of the design. So if you want to try and solve this on your own and then check to see if I get the same answer as you, you can go ahead, pause the video, talk it over with mom, or write down your process and your answer, and then we'll check back in. So you can pause now if you would like, or if you are just going to follow along and blow through this, that's fine, or welcome back. So you're going to find the area of the semicircle. So we know that the radius is 160 millimeters, right? So the area of our semicircle is going to be half pi radius squared. We're going to plug our numbers in. We're going to simplify where we can. So I can already take 80, right? 2 out, divide this in half would give us 80. Then I'm going to multiply my numbers together. The area of the semicircle is 40,192 millimeters squared. To find the area of my quadrant, they give you 30 millimeters. So 1/4 times pi r squared. Plug my numbers in, cross simplify where I can, right? And that leaves me with 1 times 3.14 times 15 times 15. The way that they did this, in case you're wondering, is 4 is 2 times 2. So we took the half of each of these 30s to get 15 times 15. Okay. So that's going to give me 706.5 millimeters squared. And then I'm just going to subtract the area of the quadrant from the area of the semicircle. So 40,192 minus 706.5 is going to give me 39,485.5 millimeters squared. So the area of the green part of our design is going to be approximately that number, right? All right, so you can go ahead now and you can either continue on. There's one more learn that we're going to do together, or if you would like to work on numbers 4 and 5, you may. So if you want to pause, this is the point to do it. If you're not going to pause and you're going to continue on, let's go and move forward. So the last thing that we're going to do is solve real world problems involving rates and circles. Right, so you're going to have to think back to course 1A where we did rates. So we're looking at the tire of a car, which has a radius of 10.5 inches. We're going to try to figure out how many revolutions the tire would need to make for the car to travel 13,200 inches. For this one, they're going to use 22/7 as approximation for pi. So the way that we're going to solve this is we're going to solve for the circumference of the tire. And then we're going to find the number of revolutions by dividing the distance by the circumference of the tire. So let's find our circumference first. Again, if you want to pause this, solve it on your own, and then check back with me as I move through, you may. So to solve for circumference, 2 pi r, we're going to plug our numbers in. It's going to give us 66 inches. So we're going to say that the car travels approximately 66 inches with a single revolution of the tire. Now, if the car needs to travel 13,200 inches, we're going to divide that by 66, right? Which is going to give us 200. So the tire is going to need to make approximately 200 revolutions to travel 13,200 inches. Let's do this with our field example 2. So a field is shaped like the diagram below. So it is a rectangle with semicircles at the two ends. There's a running track around the field. Okay. we're going to use 3.14 in this example. So part A is asking us to find the length of the running track. Round your answer to the nearest 10 meters. So we're going to pretend that this black line is, is the running track. So we're going to, again, we're solving for the circumference or the circumference of my semicircles, which, sorry, I think we're good now. Which we have two semicircles. It's really just one big circle, right? So we can just solve for the circumference of the circle. My diameter is 64 meters. So since they're the same length, we're just going to solve them as a circle, right? So 2 times 1/2 times pi d, which really is just pi times diameter, which is going to give me 3.14 times 64 for a total of 200.96 meters. So now to find the length of the running track, we're going to take our semicircle or our circumference of the circle and add it to the length of each edge of the rectangle. So, which is going to be 100 plus 100, which gives us 400 meters because we're rounding to the nearest 10 meters. We can drop our decimals. An athlete ran around the track one time at an average speed of 8 meters per second. How many seconds did it take him to run around the track? So we had an average speed of 8 meters per second, right? We're going to take our formula for time, which is distance divided by speed. So if we know that the distance that he traveled was 400 meters, we're just going to divide that by 8, which is going to give us 50 seconds. So it took him approximately 50 seconds to run one time around the track. Finally, we have a gardener who is hired to cut the grass in the field. She cuts the grass at an average of 40 square meters per minute. How many hours will she take to finish the field? Round your answer to the nearest hour. Okay. So for this one, we're going to need to find the area of the two semicircles. So since the area of the two semicircles will be equal, we can solve it as a singular circle. So diameter divided by 2 is going to give us 32. So ultimately what we're going to do is we're going to do pi r squared. Sorry about Bruce. All right. So we're going to solve for the area of the two semicircles as we plug our numbers in. 3,215.36 meters squared is our answer. Then we're going to find the area of the rectangle ABCD, which is 6,400 meters squared. So then to find the area of the field, we're going to add this all together for a total of 9,615.36 meters squared. Okay. So now that we have the area, we're going to find the time taken by the gardener. So remember, we're going to take the area of the field divided by the rate of cutting grass, plug our numbers in, right? And then we're going to convert to hours. So we had 240.384 minutes, convert that to hours, and round to the nearest hour. So it took approximately 4 hours to finish the entire field. As you can see, for these problems, especially the ones with the multi-parts, you are going to want to make sure you are writing down your work. We have officially reached the point of no return. You must be writing all of your work down for any word problems at this point because there are just too many numbers for you to try to memorize or remember them all in your head. So please do yourself a favor. I know that you probably already do this very well. So just make sure you're writing these numbers down because you will lose track of numbers. And it will happen, and then there'll be silly mistakes, which will make it really frustrating. Right? So for the last couple of problems, if you haven't been already, please make sure that you are writing out each of your steps. Now, you don't have to write it out like as much as they're doing it here, right? Like they're like showing their cross simplification. As long as you're writing like, okay, here are my numbers plugged in, here's what they equal, right? And then numbering your parts so that way you know where to find your pieces. I recommend for now using like half of a sheet of paper per step. That'll give you a little extra space. You won't lose things. You're going to use more paper, but you won't have to worry about trying to keep things super cramped. So if you are ready, you can go ahead now. Either complete all of the guided practice or just complete the guided practice that you have left. Remember, you have until Wednesday to finish up to number, I believe it is 6. It is number 7, all of the parts. I want you to take time. If we hit the end of day Tuesday and you feel like you're not going to finish by Wednesday with the practice, the guided practice, that's fine. Please leave a comment on this assignment and I will go ahead and extend you out till Thursday. This is the one piece that I want you to make sure you're taking your time with, because it can get really confusing and really frustrating. It's not confusing and frustrating for you, phenomenal. But let's make sure that we don't get to that point. So if you do have any questions, please feel free, drop them in the comments. You and I will go ahead and meet on Wednesday just to touch base, make sure that you are doing well and you have no questions for me. That's everything for me. So I hope you're having a great day. And I'll talk with you more later, kiddo. Bye.